The chance to shape your future is here. Learn and connect with exciting new opportunities. Are you ready for the next step?
Good afternoon, everyone, and welcome to this afternoon session. My name's Louise Jones. I work at the KTN. I've got the pleasure of hosting this session, but I'm going to hand over to those that are far more knowledgeable than me on this innovation network session on cross-sector battery systems. I'm just going to highlight really the agenda for today. I'm just really the gatekeeper to all of the exciting stuff that will be on discussion shortly. Nicoletta, my colleague, will talk about the cross-sector battery systems innovation network. And we've got some great Welsh innovations in discussion for you today. And please remember to use the hub chat feature for posting any questions that you want addressed by the panel today. Jackie will coast you through the panel discussion, followed by I'll wrap up and close, but three cracking speakers online for you today. Please use the chat function to post anything you would like. And I'm going to hand over to Nicoletta.
Thank you very much, Louise. Good afternoon, everyone. Lovely to have you all here today. I'm here to talk about the cross-sector battery systems innovation network. The cross-sector battery systems innovation network is part of KTN's portfolio. KTN is all about positive change, and the innovation network program brings together expert communities from very diverse sectors. So you can see here the range of sectors we're covering within the innovation network portfolio. So from battery systems to hydrogen to geospatial, quantum, so a very diverse mix. The cross-sector battery systems innovation network has a mission, which is to create an open and collaborative environment, both for researchers and innovators in battery manufacturing. And we have three main targets: to open new markets for the battery industry, to promote innovation, and to help decarbonize a wide range of end users. So it all started by a small group, small and diverse. So founding members include DSTL, ATI, Rolls-Royce, the Railway Industry Association, some sector specialists, so AMTI, Delta, and it grew from a very small community into what today has over 350 signed up members. So here you are seeing a snapshot of a landscape map that we're currently working on. So as soon as anyone joins the innovation network, they get signed up, and then we use the information to create this landscape map. And we are hoping that we will be soon in a place to be able to publish this as part of the new online hub for the community. The group identified early on some supply chain challenges, so scale of battery systems, volume and timing, technical requirements, and market pool. So these challenges were identified a while back, and what we're doing to address this is we're trying to bring together all the experts as a community to help work through those challenges. So earlier this month, we've launched a Batteries for webinar series. The first one focused on the defense sector. We had loads of positive feedback on that. So if you're interested in batteries for defense, you can now see the recording for that. It is available on the KTN website. And we have two more sessions as part of the series, batteries for marine and batteries for rail. If you're interested, please do sign up and join us for this. There is a link here for the hub. It is ukbatteriesnetwork.org. once you land on that website, this is the temporary landing page where the actual hub will be hosted, and you will be able to sign up to get our newsletters, become part of the community. You'll also be able to sign up to the Batteries for webinar series. So please do use the address to learn more. Further plans for Q1, as I've mentioned, we're about to launch the new online hub. The landscape map that you saw earlier will be part of this hub, and Q2 will focus on making things better. So we'll get user feedback, see what works, what doesn't, and try to improve on everything. So you will be seeing more and more information as part of the hub. We're hoping that the online hub will be the place to go for any information related to batteries. So we're hoping you'll be making most use of the hub. And that is all for me. Thank you very much. I will now pass on to Peter Kern of De Regulera.
Hi, thanks, Nicoletta. Okay, hi everyone. So I'm Peter Curran from De Regulera. Thanks for the opportunity for the organisers to talk today. We are based in Caerphilly in South Wales. I don't need to tell you, a lot famous for a genuinely impressive castle and of course the cheese. Hopefully one day it'll be famous for us. So we're a small company, 14 permanent staff. In the materials department where I work, we're developing not only the sodium-ion battery anode materials we're going to talk about today, but also supercapacitor materials. And before we move on, a quick plug for our engineers who are developing in-wheel hub motors, the power electronics to drive them, and the EV prototype systems to demonstrate them in. If we're going to talk about battery materials, the story really starts way back with the Baghdad cell that you might imagine maybe Mary and Joseph used to power their bottle sterilizer. About 150 BC, the first ones of these were dated to, and there's tens of these have been discovered. So the battery materials here are iron and copper, which is a pretty good choice actually, and they're found in this interesting arrangement. And there's evidence of acid corrosion on the metals actually, and in the modern day people have remade these devices and filled it with grape juice or lemon juice and found that you get an appreciable battery. And then we'd leap on maybe 2,000 years to the voltaic pile. You might remember pictures of something like this from your school days. So this is where you take two different metals and you make an alternating stack of the two metals and you separate it with cloth or cardboard, and you soak the cloth or cardboard in seawater, and that makes a decent battery. Zinc and copper were found to be a pretty good pair in there. I don't know about you, but when I think about this device, it's always associated with this picture from dusty old school textbooks of the dreaded frog's legs twitching experiment and the accompanying shudder that comes with those memories. I think Mary Shelley put pen to paper shortly after those experiments. And then we take a relatively small leap on, so another 59 years, to the birth of lead acid. So I've used the modern stock photo there. That's the 12-volt starter light and ignition battery we all know and love from our cars. They give you a headache every 4 or 5 years. Although if you're not going out to start your car for a couple of months, then you might give you a headache in a few months actually. Here the materials were slightly more complex, a lead oxide and a sulfuric acid. And then at the turn of the 19th century, there was a switch from acidic electrolytes to alkaline ones. They weren't packaged like that in 1899, obviously, but just goes to demonstrate that it was the same technology back then, always through the next few chemistries. So nickel cadmium, nickel metal hydride, these might be familiar to you. These are all alkaline electrolytes. And the next big jump was in the 1970s, with a switch from water-based electrolytes to the non-aqueous electrolytes, and a jump from about a volt to about 3 volts. Hot on the heels of this in the 80s was the work, really the birth of what we now call true lithium ion. So this is where lithium metal was swapped out for graphite carbon, and lithium cobalt was developed. So this was a layered oxide, and this really heralded the age of quite complex materials discovery, and that was awarded the Nobel Prize. We'll call it last year. And then we can ask now, what next? So you may have heard of some of these: advanced lithium ion, metal air, solid state, lithium sulfur. All these have got their worthy technologies with their own benefits and challenges. Today, I'm going to talk to you about sodium ion. So we've chosen sodium ion because, for a host of reasons, one of which is that the ratio of sodium to lithium on planet Earth is about 1,000 to 1. So it's truly sustainable. Pretty soon, in the near future, not too distant future, there's going to be 10 billion people on the planet. And if everyone's going to have access to battery energy storage to reduce their tailpipe emissions and to mitigate the transient nature of renewable energy, and I think sodium's probably a better idea. Not only is it more abundant, it is geographically evenly distributed in the oceans. We don't require African blood cobalt. Another technicality is we can use aluminium on both current collectors, and all this boils down to quite a pessimistic estimate that will be 30% lower cost than lithium ion. We're also safer, so we're more sustainable, low cost, and also safer. We can discharge to 0 volts and short the terminals. Lithium ion can only discharge maybe 30, 40, maybe 50%. And so we can remove the electrochemical precursor to battery fires. A lot safer to transport. Well, I think we'll hear a bit about that from Mike in the next talk. And we can avoid the quite stringent transport regulations. That's quite a serious headache, actually. And I won't get into the chemistry, the technical details, but there is a quirk of the chemistry, which means that we theoretically we could be higher power than lithium ion. So that's all great. So why not? Why aren't you hearing about it? Sodium ion, why aren't you using them yet? Well, it all comes down to energy density at 140 watt-hours per kilogram at the cell level for a current prototype. It's about 1.5 times bigger and heavier than NCA and NMC based lithium ion, and maybe equivalent to the high power LFP based lithium ion. If these acronyms are new to you, don't panic. Just suffice to say that not all lithium ion batteries are equal. There's different chemistries, and we anticipate sodium ion is going to break into different chemistries too. So where are de Galera in the supply chain? Well, if on the left of the screen, we have people who remove material from the earth, and on the right of the screen, people who use batteries. So we're somewhere in the middle. So we buy high purity materials off distributors like Alpha ASAR and Sigma Aldrich, much like universities do. But of course, we're thinking a lot bigger. We're thinking about tapping into bio-waste streams in the UK. And then we take these materials, we wave our magic wand, add a sprinkle of fairy dust, we turn it into a battery material. And then it gets interesting, because then we need to scale up and we need to talk to people like the CPI, William Blythe. I won't list them all. After that, we need to talk to people who can make prototype cells of industrially relevant packaging. And at the same time, the industrial cell manufacturers like AMT Power and UK BIC, we've just seen a lot of these logos actually from Nicoletta. And I've just named 2 of the OEMs I've talked to, but there's a whole host. And we've actually found through our growing pains that we've had to bring on a little bit of these 2 in order to facilitate the discussions up and down the value chain necessary to generate the interest and get things moving. So a bit about our portfolio of sodium ion materials. There's 4 materials, which until I can think of a snappier name, I'm calling DEN 1, 2, 3, and 4, where DEN is energy density. So these are going up in energy density, so they're getting smaller and lighter, and they're going up in cost. So I'll start with DEN 2. This is called a hard carbon. As the cartoon suggests there, it's a bit like a disordered graphite. It's a tricky beast to play with. There's probably 4 or 5 material parameters we need to keep an eye on to control and to optimize for sodium storage. Normally, I'd suggest this might be aimed at something like a lead acid replacement. If we want to go to higher energy density, so above 140 watt-hours per kilo and something up to approaching automotive lithium ion, then we need to make a composite. So this is where we arrange nanoparticles on the surface in a core satellite morphology. So these particles are a conversion or alloy material. So the core hard carbon is a conventional intercalation material. So this composite material has a different electrochemical reaction, different pathways, very high capacity. You can't make the whole electrode out of that material because nature's fun like that, and it tends to make things interesting for you. We're normally targeting that at something like the 48 volt systems. And then a bit wackier, to approach full high voltage electric vehicles, we have a different composite under development. So this is where we take our hard carbon and we coat it in alternating multi-layers of a 2-dimensional material. So you may have heard of graphene, which won the Nobel Prize probably a scary 10 years ago or something like that now. So that won the Nobel Prize because it was shown that the physics changed quite dramatically when you went from 3 dimensions to 2 dimensions, and that was new. But it's not unique to graphene. There's a family of materials called transition metal dichalcogenides. And actually, if you think about arranging different alternating layers, you actually, every time you do that in a new combination of them, then you make a new material itself called a metamaterial. And there's over 100,000 combinations of metamaterials. And we're screening them theoretically, simulating them for sodium ion storage. And we developed a process, a proof of principle process to fabricate this type of material. And finally, Den 1, you might think it's a bit odd to put an extra work in to go to a lower energy density. But the trick here is trying to drive the cost down. We're trying to remove a high temperature and furnace anneal from Den 2. And we're doing that by coating our hard carbon. Sorry, not coating it, we're playing with the surface functional groups. So these are dangling chemical bonds that we can play with and play some neat tricks. So that's a lot of work for a team of 5. Obviously, we can't do it ourselves. And this is all facilitated by the collaborative R&D opportunities from the Faraday Battery Challenge through Innovate UK. So far, we've pulled ideas through from these universities, and we spent the last couple of years forming an inner circle. So the CPI, the Centre for Process Innovation, perform the techno-economics at a very early stage, low TRL, help us understand how we'll scale up our materials. Kinetic are there for cell scale up, and MPL for advanced measurement techniques. And then we need somewhere to think about putting the batteries. So I spent quite a lot of time talking to the team at Specific, the buildings as power stations demonstrators down in the University of Swansea. We hope in the first half of this year, we'll have a demonstrator cell there with one of their solar windows or a solar panel. Fradian and Anti Power, a sodium ion cathode material and cell manufacturers in the UK. So I'm speaking quite heavily to those two. These kind of semi-transparent logos are all people I'm talking to, and they're in the wings to work within future rounds of collaborative R&D. And all of this is underpinned actually by our integration to NextGenna, which is a £12 million 4-year Faraday Institution project led by University of St Andrews, involving all of these researchers, and we get to swap materials and knowledge and information with these. And the future is quite bright. I think it's a good time to be an SME in the energy storage industry. Thank you very much for your time. Apologies for overrunning slightly, Nicoletta. I'll stop sharing and I'll hand over to Mike Valentine from Triwall.
Thank you, Peter. Good afternoon. Sorry, I'll just get my slide up. So my name's Mike Valentine. I am projects lead for Triwall in the UK. Triwall is a global technical packaging company, and the UK head office is based in South Wales. So what I'd like to do is share a quick overview of some innovative packaging development that Triwall's been working on for the past 3 years. I'll run through with you a little bit about the demand, the research and development work that we've done, and some of the quite interesting product outputs that have come from there. So demand, we see a lot of these graphs and tables, but if we look at 2019 as a base point figure, 1.3 million vehicles were manufactured in the UK. And if you look at the ban in 2030, and the same volume of vehicles, assuming 7,500 cells on average per vehicle, potentially we're looking at a minimum requirement of just under 10 trillion cells to meet that demand. That's just in the new vehicle manufacturing. In old vehicles, we're going to have end-of-life product coming out for recycling and relifing. Plus, we've got static storage for domestic and commercial. So there's going to be an awful lot of cells and batteries that are going to need moving around, and we need an appropriate way to do that. So similar to Peter earlier, some of these things need to be done with a group of experts rather than individual business. So we put together a collaboration, and the collaboration looked a little bit like this. The collaboration was around the safety from everything from cell manufacture to end of life and transportation. So we have Jaguar Land Rover, as we know, one of the largest vehicle manufacturers in the UK. We have a good relationship with those. 3M for chemical technology support there. Health and safety executive, very good partners to support us with testing and approvals. Denshi Power, got good connections with the Ministry of Defence and the requirements there, which differ slightly sometimes from what the normal automotive industries require. Warwick Manufacturing Group, mainly for their expertise, they tend to be involved in an awful lot of projects like this. Lifeline, who are fire mitigation systems. Potenza, battery management systems experts. And Warwick Fire, again, links Warwick University for their expertise in modelling what we need to deal with. Again, we fortunately had the government support to enable this project to go ahead through the Faraday Institution. And that allowed us to start the project a little under 2 years ago, and is due for completion in March. So, how did we approach this? First thing we needed to do was hazard mapping exercises. We did these both with industry and with the general public to try and get a balanced opinion of what the issues and requirements were. We did an awful lot of testing at the HSE to understand what the issues were and how we needed to approach them. So, in the main, we needed to understand that we need to transport the cells. Cells can be in many guises: cylindrical, pouch, prismatic. We need to look at the modules for automotive and static storage applications. And then ultimately full vehicle battery packs, which could be for road vehicles or off-road. So a lot of us have seen these before, but I'm going to run a quick video to show you what an issue could look like with a cell in thermal runaway, which hasn't run. It's jump back slides. Bear with me a second, please. Okay, so we've all seen these before. They're quite aggressive chemistries and need to be handled in a very specific way. So what we needed to do was develop a cost-effective, lightweight packaging that could cope with a number of issues. The first issue is if a cell goes into thermal runaway, you have approximately 1 litre of gas expansion. You can have the ejection of the jelly roll at up to 100 miles an hour, so you've got an impact velocity within the pack to deal with. And then you've got the temperatures involved in that thermal runaway event. Thermal runaway in cells is almost impossible to stop once it's occurred. So what we need to do is manage that energy that comes from it so that it doesn't escape the pack and also doesn't allow propagation to neighbouring cells. So if we look at the visual on the screen there, this is a pack design we did with UK BIC. It's anti-static foam with cutouts for 64 cells in this particular instance, which is then top and bottom layers to stop any contamination, so they come straight from clean room into this pack. An impact sheets to do with those velocities. And the green material I'll talk about a little bit more in a second is the developed material to manage that thermal propagation. And then that needs to go in an outer pack, which is suitable for transport in the way that we normally move things around for stackability and storage. So the material we developed, which is the green paper-based element here, it is an FSC compliant product. It is paper-based, it is fully recyclable, and it does not give off any toxic gases, which has been a bit of an issue in the past with dealing with these things. We are looking for that material to have heat shielding, but we've also found a way to impregnate it with an endothermic property that can then take the energy away from that single cell, stop it propagating through the other cells within the pack. We need to also manage the external temperature of the pack, which under current regulations cannot exceed 100 degrees, and we're not allowed to have flame exceed that pack also. Okay, so what does that look like? Here is a test where we put 64 live cells of the type we saw earlier into the pack. They're all charged to 30% state of charge. We initiated thermal runaway in 6 of those cells randomly positioned in the pack as simultaneously as absolutely possible. So I'll run the video, but so we're looking basically to have no flame outside the pack, for the pack integrity to remain, and for the external temperature to be below 100 degrees. Sorry, my video's jumped again. Let's run that for you. Quite a short event. So there is, you can see, some gas escape there. So it gives a visual indicator of what's happening. And that's the full event over. Needless to say, the 6 cells were destroyed. The foam material around as well gives way, but there was no propagation to any of those neighbouring cells. There's no flame outside the pack, and the surface temperature, I think, didn't actually exceed 40 degrees, where the internal temperature was just over 400 degrees. So that's in the small cell pack. We can apply the same technology now to larger packs. So we can do that with corrugates and timber base. If we're shipping full vehicle battery packs, there's a timber solution on the right-hand side, but we can apply the same chemistries to. That's collapsible, so we can put into a return loop as well. So we've learned an awful lot in this project, and it's information that we want to share. We have, before lockdown, attended a number of public events where we've shared the findings, the R&D findings that we've gone through the project. We are looking to publish the information and knowledge at the end of the project in March and make that readily available for anybody who needs it. So this leads me on to this slide. We get asked all the time, how do we interpret the packaging regulations for shipping cells? I'm conscious of time here, so I'll be very quick. So we put together this decision tree basis where you decide at the top, is it likely to create an issue or disassemble? If the answer is yes, you go straight to the group 1 box on the right-hand side. If not, then you say, if the cells are 38.3 certified, if they're in good condition, you follow the channel on the left-hand side of the chart. I've also put in the relevant packing instructions so that you can understand what needs to go with it. If it's not likely to disassemble, in UK road transport, you currently do not need UN dangerous goods certification. If it is likely to cause an event, or the cells are not 38.3 tested, or if it's in an unknown state, and you follow the right-hand side, we have made some assumptions based on weight and size as to what the point is we go from corrugate into timber and so on. The group 1 box, we have, and this is probably something for a future video, we've reinvented the definition of a group 1 box. We've produced a composite laminate, lightweight, cost-effective version that is very returnable. We are currently just getting approvals through the VCA because it's a new type of pack and they actually haven't got a set of standards to approve it by. That will be available by the end of March. I'm Mike Valentine, Projects Lead for Tribal UK. Please do contact me if you need any other information. Dukavar, thank you very much, and I will now hand over to George.
Thank you, Mike. Very interesting presentation indeed. If I can start sharing my screen. Hello, I'm George Chamberlain. I'm a senior manager for the Trahan Group. I oversee all the electrification activities for Trahan Automotive Engineering and EV Marine, and I also oversee the activities for EV recycling. Trahan Automotive Engineering started approximately 10 years ago, and we have started venturing into the electromechanical systems, research and development, but recently we found ourselves supporting our electrification automotive OEMs into supporting their endeavors. From Trahan Automotive Engineering, we have started up EV Marine and EV Recycling approximately a year ago. EV Marine is based in Swansea, and the primary target of that company is to roll out electrification propulsion systems in the marine industry. EV Recycling, which is what I'm here to talk about, is a company based in Llanelli in South Wales, and is the only company in the UK that can test, reuse and recycle lithium-ion automotive batteries in the UK. EV Recycling was initially set up to support industry end-of-life needs. Our expertise in electric vehicle and high voltage battery system has allowed us to support our automotive manufacturer customers' needs, battery manufacturers and other different market sectors in many aspects, such as little as battery storage, logistics, battery evaluation, diagnostics, maintenance, remanufacturing, repurposing, obviously recycling. And also we found ourselves consulting into the different aspects of the battery technology, from a complete electric vehicle, tooling and safety as well. At the moment, as a recycler, we have been researching what's happening in the UK, Europe and globally in general. But for the UK, we are seeing some trends. So definitely, as other presenters have said, there is a tremendous growth in electric vehicles, as you can see from the Department of Transport data there from the DVLA, that there has been an increase in electric vehicle registrations in the last few years, and there is a decline in diesel and petrol vehicles. Alternative fuel, meaning in particular battery electric vehicles and plug-in hybrid electric vehicles. We're seeing a lot of growing environmental awareness from different people in different industries. So, and they are, people and companies in general, they are becoming more conscious of what emissions different things emit in life at the moment. We're seeing a trend in home energy storage for both brand new battery support units and reused battery energy storage systems. Different automotive OEMs have started rolling out vehicle-to-grid support on the vehicle. So for example, a vehicle can be plugged into your house or a premise, and then the vehicle can be charged using the same socket, but as it's charged, and when it's not charging, can support the building if it can. We're also seeing a big growth in the battery sector in general, from research and development projects in recycling in particular. Also, there are more battery factories in the UK now than ever. There is a lot of grid support from the battery sector at the moment. And also, we have noticed that a lot of consumables have started considering using lithium-ion batteries to fulfill their needs. In the recycling world, there is investigation constantly to see how we can recycle lithium-ion batteries more efficiently, in particular direct recycling. So using that anode material again into making a new battery. And in particular, that goes down to the circular economy. So ideally, in our vision, will be to have the battery manufacturers in the UK producing lithium-ion batteries. The batteries go to have the first, second, third life. And then when there is need to recycle, we recycle them, we refine them into the appropriate specifications, and then they go back to be reused as batteries again. And that percentage of reusable battery at the recycling stage is important to us. And we have also noticed a trend for switch over to renewables. You've noticed our electricity and gas providers already switched, and also different sectors in different industries from construction, they are switching over to renewables. What we see as our areas of focus, which can also be considered as opportunities, is battery reuse, for example. So we have a saying and a motto in EV recycling where no good kilowatt goes to waste. So we are actually investing heavily into making sure we, if for example a module comes in and is faulty for whatever reason, we're not looking to scrap the whole module or recycle the whole module. We're looking to remove the good cells, reuse them and be part of a brand new module or a brand new battery, brand new second life battery that is, and then only the waste cells can carry on into the recycling. Also a big opportunity now with EV recycling relevant permits and licensing. We can have a UK-based recycling, so we can no longer need to send certain aspects of the recycling process to other countries. We're also seeing now that a lot of the vehicles that started the lithium-ion technology some years ago, they're coming to the end of their life in the EV sector, and they're starting to go away from the OEM warranty. So those batteries, they need to be tested, and if they can be reused, they can be reused and then go into the recycling process. Also, we are seeing an increased appetite and capacity to build new products from reused materials, especially from items that previously have been using lead-acid batteries. And also, in our industry of recycling, there needs to be a better understanding of battery aging. And with having access to a lot of different batteries at different stages of their life through testing and metrology, you can understand better of what that battery aging will be in that second or third project, or life it will have. And also now we're starting to see more acceptance from the general public, of the battery tech. So they're willing to take new, they're willing to venture into new applications, so using products that they have lithium-ion batteries in them, in particular second life lithium-ion batteries. So how can Wales capitalize on this? I mean, Wales has great talent, and to be fair, most of our workforce are local. They are Welsh. They finished from and graduated from local universities here in Wales. We have really good contacts with our universities here, and we are working together into understanding if we can materialize different projects. We're investigating many projects with them, from automation of the recycling process, and also to the reusability. Having now that permit, that EV recycling permit, to be able to recycle lithium-ion batteries is a huge step forward. It will allow us, it opens the door in so many different aspects. There is an opportunity, which is where we are at the moment, is to see if there is an investment in refining tooling and methodologies, because the next steps for us will be to understand the best methodology to go into the refining processes as well, and also explore direct recycling further. And now with EV recycling in South Wales, research organizations, we have so many of them, they have the opportunity and access to second life batteries, which can reduce drastically their R&D costs than buying a brand new battery. And also, we can start a small and large battery manufacturing from cell and module level at the second life batteries. Also, what I wanted to add on this is that although EV recycling has started with the permits on EV electric vehicle lithium-ion batteries, we have the capability to recycle up to 500 tons a year of material initially. We have very close relationships now, and we have been working very hard and very close with NRW and the Welsh government to make this happen. And the permit is always open for us to expand and change and alter as the technology and this sector matures and evolves. Thank you from me. I would like to pass on to Jackie.
Hi guys, can I invite you all to come back onto your cameras and say hello?
Hello.
Fantastic set of presentations. Blown away by all of them. Really fantastic to see all the work that's going on in Wales. So we've got some questions coming in. So people who are out there, please do send us more if you have them. But we're going to sort of start. I think, George, you segued really nicely. You were talking about Wales and why you're in Wales. And I think I'm going to ask the same question. I think you covered it really nicely, but I'm going to ask the same question of Peter and then Mike. So Peter, why are you in Wales? What's the upside?
Yeah, good question. Thanks, Jackie. It is an interesting question. I think One thing I like is that all the talks, we all touched on the fact that to succeed in the battery industry, it requires a lot of collaboration. It's not just with other industry, but also with local government, I think. I think regulation and legislation is going to play a huge part in how we commercialize this technology. I sense that the mood music in Wales is slightly more favourable, I think, than the rest of the UK. I like things like you see terms like the term climate emergency appear to be adopted and used a lot more openly in Wales than elsewhere in the UK. You look at things like the M4 relief road, when there was, I don't know how much money was gone into that, and you think from afar, you're watching that and you think, really, after all this, everyone's saying there's a climate emergency, we want to do something good about it. I was so chuffed that they had the guts to say, actually, they took the tough decision really and said, we're not going to build that road. And it just showed that there was some stomach to make those tough decisions, not just to go with make the easy one, and I thought that was great. And I think on top of that, I think the success, we're going to need to collaborate. And I think it's not a cliche to say that there's quite a tighter community feel in Wales, I think. I notice we haven't got everything in Wales, so I speak to people from all over the UK, but I noticed that when you speak to people from maybe the peripheral regions, that there's a lot more feeling of let's get on together and do this, because if we're going to succeed, we're going to take a lot of companies with us. We're all going to rise together. So I think there's a tighter community feel, I think, which is helpful. That's my answer.
Yeah, and I like that. I like that as somebody who used to work for Natural Resources Wales as well, to hear George, you're talking about the political direction, and George, you will have been working with NRW, so I'm going to have to find out who afterwards on the permitting side, and so that direction is useful. I think that community field's really important. Mike, it was fun to listen to you and George beforehand saying you need to catch up afterwards. So what's it like for you just on the border of Wales? Is it important that you're this side of the border?
Yes, very much so. I think firstly, it's important to recognise, we are a global business, and it's certainly known that the technical knowledge sits very much in the UK when we look at Europe as a whole. And then if you focus that down more so and look at the output from the universities in South Wales, we recruit wherever possible from those universities. And the knowledge and skill set that's coming out currently for people who have a very broad open mind to new technologies is incredibly valuable to us as a business. And I think that probably stems from what was mentioned earlier. It's the government drive in South Wales towards disruptive change. If we look at the promotion of these technologies, it's potentially a high-risk environment, and it takes someone with an awful lot of confidence and foresight to say, are we going to support these businesses and be industry leaders? The Welsh government does that extremely well, and the results are very, very visible. And when you look at the industries that are coming out of South Wales, supported by the university graduates and the technology there. So for us, yes, it's a technical base in Monmouth. We do benefit from our position in South Wales, and above everything else, it's a beautiful part of the country.
Yeah, I think we all enjoy living here in Wales, I must admit, even if my job is all of the UK and I have a strong South East England accent. Right, I'm going to ask some technical questions. I hope you're ready for this. So I'm going to start with you, Peter. I've got one here about what sort of prototypes are you currently manufacturing and what methods are you currently using to do so? This might be from one of your competitors, you never know, so keep it vague.
Good question. I don't mind saying we're at the single layer pouch cell level. Hold on, let me just say, get lost to one of my kids.
Okay, well, as Pete says that, I'm going to ask one, I think to you, George, are people accepting, do they accept recycled batteries? For me, there's a huge amount of knowledge you need to have of those batteries before people will accept them. So do you want to talk us through how you do get people to accept them and what's the criteria and specifications you're using?
So first of all, We have projects that they are reusing second life batteries at the moment, and they are out there in the UK. So people do accept recycled batteries. So I guess from a different point of view as a consumer, we have, for example, a price bracket. Depending on what batteries a customer will need, they will have a look or if that is going to be efficient or viable in what they're trying to replace. It might be an engine, it might be a lead acid battery. And if that makes sense, and us as a waste producer and as a second life battery supplier, then we can guarantee that battery is going to last for the amount of period that they need them. It might be a year, 2, 3, 5 years. Then there is no question if it's okay or not. So we, as the Trahan Group, we have been developing battery test equipment for some time now. So we know very well how to measure the state of health of different batteries. We know very well how to assess the BMS. We are creating our own BMS systems. So we have very good understanding of the lithium-ion batteries. That's why we're so comfortable in supplying second life batteries, recycled batteries to people and the industry.
So what applications are those? I'm sure there's people out there are going, you know, who are using your batteries right now in second life applications? So
I can disclose one application, which is replacing of lead acid batteries with lithium-ion batteries in the sector of mobile security systems. So for security cameras in remote locations. So that had a big interest. So that's something I can disclose. That's
a really interesting application. Yeah. Okay. That's great. Peter, we'll come back to you now. Have you managed to adios the child?
Yeah, I didn't say get lost. I went and warmly supported them with their homeschooling task, obviously. Yes.
So going back to yours, it was all about what prototypes are you currently doing?
Yeah, we spent about a year and a half, maybe 2 years with hand-coated half cells. And then we've been manufacturing single-layer pouch cells at Kinetic. We're on the cusp of double-sided electrode multi-layer pouch cells, so something about the maybe 5 to 10 amp hour, so getting quite big. I touched on the value chain, so if I want to stimulate conversation up and down there, everyone asks who's at the end. So then I go to the JLRs and the Nissans, and they say, what have you got? And if I haven't got data on a double-sided multi-layered pouch cell, at least 5 amp hour, they just say, don't waste my time, I don't want to talk to you. Working with Kinetic is great, they're really good, really expensive. We couldn't work with them outside of Cloud's R&D, we simply couldn't. But we are in the process of commissioning our own prototype pouch cell line. It arrived in the new year. By the end of March, I think we'll be making our first cells. We've got a goal with Kinetic, supported by Kinetic, to get a 100 watt-hour sub-module into specific, in harness with a solar panel, solar window by the summer.
Interesting. So obviously Kinetic just outside home counties based, aren't they? Just out near Farnborough. But everything else there you're mentioning is very Welsh centric. So that's a great example, and thank you for upping the advantages of or bigging up the advantages of being in a collaborative R&D program such as Faraday. Can we just talk for a moment, guys, around certifications? You've got a question asked, Mike, about how painful is the certification process. Let's step back for a moment. In terms of how you see the regulations and standards out there for batteries, what's your biggest pain point at the moment? So I think if I ask you that first, Mike, and then George, maybe I'll come to you.
Okay. So it is a process. Doesn't necessarily have to be too painful. But it is influenced by quite a few authorities rather than a single one. So the biggest difficulty is the regulations we are working with at the moment weren't written particularly around the current technology. So there isn't a hard and fast black and white check sheet, if you like, of what needs to be done. A lot of it is a knowledgeable interpretation of the regulation that is there. We speak almost daily with the authorities. We specialise in UN dangerous goods, so we need to have these conversations. And when we speak to the VCA, ADR and IATA, they are very much having to look at the current regulations, not restrict manufacturing, but find a suitable interpretation that meets the requirement and still encompasses the safety that's necessary. So I'd say that's the most difficult part, is for people to interpret the current regulations.
Mm. And is it in respect of fire, in particular, the fire hazard, that the gap of knowledge is, or is it just the product itself in terms of lithium-ion and others?
I think it's the definition of fire. The previous definition of fire was around materials and liquids that you just starved of oxygen and it was resolved. Whereas batteries, as we know, act more like an aerosol. They are oxygen generators. So it needs some technical understanding of what it is that we're dealing with before we know how to react to it. And we're quite fortunate that the project we've done has allowed us to map those elements. And we're trying to feed that information now to those authorities so that we can support them and work with them.
Great, I'm going to catch up with you afterwards. George, what about you? If you could get one bit of regulation or one standard updated, what would it be?
Well, a new one would be good. So yes, in particular, there is no, we are actively looking at the regulations regarding lithium-ion batteries, and they are ever evolving, as you can appreciate. We are seeing regulations into the review phase, but in particular, when it comes to recycled batteries and reused batteries, there are two things that we are looking for. First of all is the UN 38.3. I think Mike is actually looking at that as well. So if the battery has that standard, it makes our life a lot easier to be able to reuse it as a first step. If that regulation is not there, it's very difficult to put a battery into the field, into the market without that standard at the moment. Second of all, as soon as you create a battery, then from different modules, different products have different requirements, and then you have to see it as a new battery. So then we'll have to follow all the necessary EMC tests, safety tests, and we're using different test houses in the UK that we work with, to be able to show and be able to prove our safety capabilities for the battery. And for example, EV Marine, we are in the middle of developing one of our first batteries in the marine sector, has completely different requirements than the automotive sector or the grid support sector. So the marine, we will have to speak with people like the authority bodies, like the Lloyd's Bank, which is actually Lloyd's of London is actually who writes the regulations for different vessels and approvals. So we'll have to liaise with them. If our customer is in Europe, we'll have to speak with DNV, the German counterpart authority. They have different requirements. So yes, there is a lot to consider with regards to certification. It's not as straightforward as, yes, this battery was in a vehicle, you might as well reuse it as is. There are a lot of considerations. And also when it comes to the BMS, the software needs to conform into different protocols, as you probably are aware, depending again in what market you're going into.
Oh, it's just not straightforward, is it? You can see why an innovation hub, getting people's brains together, has been really useful. Right, where are we? So I've got some more questions that have come in. So question for you guys, how do you see the future of mobility developing in Wales with trials of England of micro-mobility, e.g. e-bikes and e-scooters? I guess hands up who's got an e-bike or e-scooter on the panel. No, I have a Segway. I'm not sure that counts though, and I can't ride it. It's for the kids. So yeah, what's your view on these new developing applications? George, I wonder if, 10 years ago, you'd have thought you'd be making batteries for marine applications.
No, definitely not. With regards to capability in Wales towards mobility, I think there are, I've been part of different panels in the year before last that Wales is constantly looking for manufacturers in order to have their home in Wales. And there is great support in government. I don't know in particular what is happening in those two sectors, but definitely us as a recycler and someone that is able to say that these batteries can be reused, there are batteries that can be reused in those applications because they're lesser power thirsty than the first life, if you like. Also, I would like to comment on the fact that it was with great sadness. I think we all saw that the battery gigafactory was possibly going away from Wales to the North England. But hopefully now that we have an EV recycling license here in Wales, I don't know if that's going to be enough to change their mind, but it's definitely something worth considering and speaking to British folk.
Yes, I think on that note, there aren't many sites in the UK where you have the availability of a big node like this St Athens site. I know the Blythe site has a renewable, has a big offshore, what do you call it, offshore generating site, which comes onshore there. And so there's a good source of low carbon for them. I don't think that's the end of that story, whether that's the end of the British Volt story, but it's certainly a very attractive site in Wales, and we'd hope with a lot of the news and noise around at the moment, such as Nissan staying in the UK, yes, you might see some good news, which we desperately need after 2020 in all its glory or lack of glory. So I've been told we've got just only a few more minutes that we finish at 15:15. So I'm just going to, Louise, tell me if I'm wrong, by the way. So I guess what I wanted to do was spend a moment to sort of reflect on Peter and Mike's experience in the Faraday Battery Challenge, and to see whether you can convince George that he might want to join us as a network and as an opportunity. And then maybe, George, if there was one thing that the UK government could do that would really support your business development, I'd be really interested in hearing that too. And Mike and Peter, your views on that too. But if we start with, what's it been like working with us in the Faraday Battery Challenge? Peter, over to you.
Yeah, okay, great question. It's been like night and day, actually. It's really positive, only positive things to say about the Faraday Challenge. I think the benefits started from when you start writing the proposal, actually. Even if you don't get a proposal, just going through the process of the 10 questions and the contacts it forces you to make and you speak to, that was kind of almost transformative in a way, in a small way for the business. And then when it kicks off, just the opportunity every 3 months to sit down in a room, okay, it's been a while, but we sit down in a room with the whole supply chain. It's just so valuable. And every single meeting I've been to, even in 2020, even in the virtual ones, I left every meeting with I'd almost call them now critical contact. So you come away with 4 or 5 contacts, but at least one sticks every meeting. It's like, we're in the valley of death, as they call it, the mid TRL range. And it's like, I describe it as, at one point I was kind of like lost in this foggy desert, and then it's like Ray Mears parachutes inside you and taps you on the shoulder and says, it's this way. And the support of the community is really useful, I think.
I like the idea of stumbling through the desert, bumping into each other, but we do try and coordinate those coming together, so we actually do have some answers. Mike, what about for you? Because I remember the first time we met, it seems like years and years ago, but it was probably round 1, all the way back when. And I think it was actually the Millennium Stadium where we had been running a cohort event.
I think the first introduction was actually by our friends at the Welsh Automotive Forum.
Oh yes, that's right. That's right. Yes, yeah.
No, I remember it well. Tribal at the time had a lot of ideas of things that we needed to do, but without the resource to enable those to happen. So yeah, from our first conversation of actually applying for funding, I'll go back to Peter's comments actually, because we were submitting one that has a deadline of tomorrow. So this morning I've spent a considerable amount of time with partners, and already we are seeing benefits of standing shoulder to shoulder with other businesses that we wouldn't have really got ourselves into that position with outside of these collaboration programs. And I think to actually get into a program, a lot of people look at them for the funding elements, and the funding element is good because it enables, but the collaboration value is much greater, and the technical knowledge that you can share with those partners, that's where the real benefit to the business is, and that's where your investment beyond the project will shine out. As a infrastructure to support businesses, I go back to my comments earlier about technical capability in the UK. It's things like Innovate UK and Faraday that actually produce that ability in the UK, where other countries don't have that level of support.
Yeah, and there's part of me as well, having spent a lot of my career in Wales, that knows, George, that that's probably even more so. I'm sure when you tell me one day who you've been talking to about your waste, about your permit, I'm going to know them, right? And that's just bonkers. And when I was working on UK BIC in Coventry, I knew people as well, because it's a small world, really. Although it's, you know, it's complex and there's a lot of people involved at times, but it's a small world. And I think when you're in this niche and growing space, actually you do need to bump into people that have similar experiences, that pick you up when you're nearly dying of thirst in the desert, Peter, and keep you going, but also to share that knowledge, even if it's not quite the knowledge you exactly wanted. It's that alignment that we see, actually, even things like feasibility studies really making leap forwards from. So that's really good. So I've been told we don't have a rush, but there's no more questions going to come in. So I'm just going to pick up a few. Can I just answer one very direct one, actually? Roger Hiscott. Yes, that would be in scope for the Faraday Battery Challenge. He wants to know if some emerging tech that detects and can neutralize batteries within waste loads, therefore preventing fires in waste facilities, that could well be within scope. So if not Faraday, there's probably some other funding opportunities in Innovate UK that could be. Right, and I think, Peter, there was one for you on, do you see different applications for DEN 1? So density 1, or just a cheaper system for the future?
So yeah, that's right. You might remember my DEN 1, 2, 3, 4. DEN 1 was the lower cost material. So we might be aiming that towards stationary storage, we think, but also it's actually could potentially be a precursor to DEN 2. So I mentioned that it's about removing the high temperature furnace anneal of DEN 2 and driving the cost of the process down. Actually, what you do on the surface chemistry at that stage really affects how that material hardens, for want of a better word, as you anneal it. So no, I think the application will be stationary, probably, but just a lower cost, more cyclable material.
It always feels to me that sodium ion just hasn't had the same amount of development that lithium ion has. It's just on a similar trajectory, but just almost that it's catching up.
It is, yeah. Back in when in that work with John Goodenough and Whittingham and I forgot the name, the Nobel Prize, that work in the 80s, they were working on sodium and lithium ion side by side, but lithium worked, and because of its position on the periodic table, they just carried on with lithium. And it's only 40 years later that people have started to realize that what's going to happen, we better go back and revisit sodium ion.
Sure. So George, could I ask you a couple of questions? One is, how did you get into marine? That's a very specific one, and that's very much with my thinking around the innovation network that Nicoletta spoke about a moment ago. And then also, you know, as somebody new to Faraday, what are your thoughts and what would you like us to be doing?
Okay, so the marine industry is something that a certain group of people in the company and the director has a passion about. And also during the WAF, the Welsh Automotive Forum meeting that we have, it looked like there was a need for, and no one was doing anything about making the marine industry greener or environmental friendly. You're going out fishing and you're using a massive diesel engine where you can use an electric or a hybrid, even with hydrogen engine propelled vessel. So that thinking, that simple thinking, is how it started. And that's how we were able to materialize our facility in Swansesford. And, you know, yeah, that is the main drive, you know, the greener, to support the marine industry and the fisheries in Wales. As simple as that. And that, to be fair, allowed us to start speaking with some really big OEMs in the hydrogen industry, which we never thought we were going to be doing. But yes, you know, people like Hyundai came, you know, we met through the hydrogen forum, the Welsh hydrogen forum. And we've started conversations about using one of their fuel cells, for example. And then we're talking again with people like Ballard, another massive hydrogen producer. Yeah. So
really interesting. So I better not forget to tell you that there's a innovation network webinar coming up on marine on I think the 8th, but Nicoletta will correct me, of February, and also open right now. Have you seen the Artemis Ferry project, the £30 million project in Northern Ireland to get a hydrofoil ferry? Very different, and there's KTN have something called an IX going on. They're looking for suppliers. That is open right now. So that also, I will remind you, I'll tell you tomorrow, but just for those listening in, it's the type of thing that we're constantly working with KTN and Innovate and all our other partners like the Advanced Propulsion Centre or Aerospace Technology Institute or whoever else to try and bring that together so it's easier for companies to just go, oh, that looks interesting. That's relevant. So we'll bring that in. On standards as well, we've just published, so we published in October a publicly available specification looking at the manufacturing of packs and modules. So if you're out there in the audience and you want to see something, if you can look that up on the BSI website. And then we're launching 2 more. One on Peter, I suspect that'd be of interest to you, and Mike, probably you as well, seeing as you're traveling them around. And then one on vehicle design, George, that you might also be interested in.
Definitely.
And then we've got plans to do maybe a couple more of useful to get practitioners sort of codifying actually what they know is best practice, particularly around health, safety and environment, right? Because you shouldn't really be looking to generate company competitiveness where people's lives are at risk, right? So that's where we try and get the shares there. So okay, so is there anything else anyone would want to add before
if I can say something to Peter and also to Mike, if I may.
Yeah, please. Go.
So Peter, with regards to it's exciting, that we have people in Wales that they are looking into this, brand new technology or something that I'm seeing into a lot of papers, including some that Jackie's team have actually published, is no one seems to be thinking about designing a battery with recycling in mind. Is that something that you consider or you have in mind?
I do have in mind. You noticed when I presented one of my slides of a load of logos who we're working with, there were some semi-transparent ones there. So Emma Kendrick at the University of Birmingham has done a lot of work on the recyclability, and I chat to her regularly, and someone I see as a future collaborator. I'm still not sure if there are any points of difference between sodium-ion and lithium-ion in terms of the recyclability. As far as I understand, it'll be fairly similar. Perhaps having more aluminium rather than copper will be a point of difference, but apart from that, I'm not sure.
In the hydrometallurgy, if you like, or the frothing activities that the refineries and hopefully us we're going to be able to do, is very sensitive in what material goes in there. So first of all, the different battery chemistries, that we need to keep them separately. The anode, the cathode, they need to be separated. So I'm pretty sure there will be a new requirement specification for a sodium-ion battery. And also, although now we only have permit for lithium-ion batteries, that doesn't mean we're not going to be applying for a new technology, sodium-ion batteries. So yes, that's something we can definitely consider. If the technology picks up and people embrace it, then that's definitely something we can support with.
Okay, as soon as we have some prototypes, we're happy to send you a few to look at and see what you make of it.
Yeah, that'd be great.
George, that's brilliant. One of the things we might do with the British Standards Institute next is design for recycle, because we also want to get automotive designers really thinking through what best practice looks like and supporting that right the way through, particularly at product design stage. So I think you and I will have some long conversations around that, and good pick up. You said you had a couple of other questions.
I had something from Mike. So Mike, the work you're doing, I greatly, I've admired what you've done with your experiments and the materials that you came up with. They are very fascinating. There is a material aspect when it comes to the recycling side of things that possibly we can work together to understand how we can fulfill that requirement. So definitely, when there is a big battery or a module or a cell, there needs to be a packaging. As a recycler, we have a fourth, if you like, requirement, which is something that we call the battery mass, which is one of the outputs that comes out of the recycling process. And that's something I would be very interested in to hear your thoughts and share some ideas on how best is to transport that black mass, as we call it.
Yeah, no, very happy to support with that. We do understand black mass and transporting that type of material. If I probably add to your earlier question with regard to recycling, we currently have a feasibility bid in where we are looking to remanufacture, or not remanufacture, reimagine the manufacture of cell casings out of a composite paper-based product.
Mm-hmm.
Benefits of that, obviously, cost weight reduction, and also we can build in the endothermic flame mitigating properties as an active material into the cell manufacturer. But one of the things is the recyclability at end of life, is we're taking that metallic component away by replacing the cell casing with a composite recyclable paper material. So exciting future. It's one we're working on with Power and HSSMI. So watch this space basically, but hopefully in 12 months from now, you may see some prototypes along them lines.
Yeah, I'm very excited to looking forward to that.
Excellent. We might have to make a date to come back in a year's time, right?
We, I think I want to give credit to the universities, as I said in my presentation, that one of the projects we're investigating and we're really close in starting with them is the same panel group that was presenting for the MATE project a bit earlier before us. We're looking into robotics and automation into getting down to the waste inside the module and taking away that cell, which is bad, or the good cell, and reusing it. And I think that ties up with, you know, what you're saying there of repackaging some of the reusable cells with a different material as well. So that will be very interesting to see.
Fantastic, guys. We are going to now have to wrap up, so I'm going to hand back over to Louise and Nicoletta, but Louise in particular, I think sat up in North Wales at the moment.
Thank you, Jackie. What a brilliant session. I've learnt lots that I didn't know happened in Wales, having lived here for 20 something years. She says, coughing, not to say how old she is. Thanks so much for the session. Really interactive, lots of questions coming through. I hope the audience have found it of use and will engage with the Faraday moving forwards. And by all means, connect to any of these lovely people in the one-to-one sessions that are on the hub itself, if you want to pick up anything that you've found that was really of interest to you. And I'm just going to close with the final video and a thank you to all the speakers for taking the time to speak today.
Thank you.
Thank you.
Thanks, guys.
Thank you, Luis. Thank you, everyone.
Thank you.
Thank you for joining the Emerging Tech Fest. Join us again on our virtual live sessions or watch us on playback anytime, anywhere.
I take it we're off air now.
Nobody does speak in case the answer is no.
I know, but it's